Okay, so inequalities, like I said, are the opposite of equations. So that's when you have two sides. So what we saw so far, we saw equations. Equations always have an equal sign, hence the name equations. There's always one side that's equal to another side. Let's call this definition. Okay, so, but two things are not always equal, okay? Just like social injustice or racial injustice or many other injustices in the world, things are not always fair and equal, so they're not always equations. So that's why we talk, when we talk about inequalities. Unequal this, unequal that. For example, in the workplace, sometimes there's what we call unequal pay, when people don't get paid equally or fairly. So that's the topic today, not the social side of it or the socioeconomic side of it, but the mathematical side of it. So inequality. So A equals B, that's equation. That's equation, or we also call it equality. Okay, the opposite of inequality. So when A and B are not equal, so we say A not equal to B. Okay, so this is an inequality. So when A are not equal to B, A could be greater, or sometimes greater than or equal to B, or the other way around, A could be less than, or sometimes less than or equal to B. We will discuss the difference between these two in the previous classes when we add that little line and when we don't need it. We're going to talk about it a little bit more later. So that's basically the concept of inequalities when two statements are not equal. It could be any of these cases. But solving inequalities is quite similar to solving equations. There's one little difference we're going to talk about later. So first, let's write some examples of inequalities. These are actual inequalities. For example, x greater than or equal to 5, or 2x minus 1 less than 7, or maybe even something like this. Okay, so all these are inequalities. Again, the only difference between these and equations is the symbol, the comparison symbol. These are comparison symbols. Instead of equation, instead of an equal sign, we have this inequality. So these can be solved and can also be graphed. Maybe let's start with the graphing part first. Let's review the graphing part first because it's probably easier than the other part. So let's call this. So graphing inequalities. So with this simple one, we say x greater than or equal to 5. We want to put this on a number line. So we need a number line like this. In the middle we have 0. So the numbers go up as we go to the right. 1, 2, 3, and so on. The numbers get bigger and bigger as you go to the right. But they get smaller and smaller as you go to the left. For example, so the 0, then you have -1, -2, -3, and so on. This is what we call the number line. So the 0 is always in the middle. Okay, we have positive numbers to the right, negative to the left. So when you say, give me numbers that are greater than or equal to 5, what number would you start from? What's the first number you'd give me if I asked you to give me X, a number, or the numbers that are greater than or equal to 5. What's the
6.
first number you would give me?
6.
Say again?
6
6. Why 6?
is greater than 5.
But here it says greater than or equal to 5. So we would start from where?
5.
5. 5.
That's right, because we have this letter line or equal to 5. So we're going to say start from 5 and any number higher than that. 5 or higher will be fine. So 5, 6, 7, 8, 9, everything. But anything to the left of 5 will not work. 4 will not work, 3, negative 1, negative 2. So we just graphed this. So that's an inequality, and that's the graph of it. So we started from here, and we went to 5. What if this was just this? X greater than 5. This is greater than or equal to 5, but this is greater, strictly greater than 5.
It would be 6.
That's right. In this case, we'll have to start from 6. So 0 is in the middle. 6 is somewhere over here. Or here. So we said, give me a number that's greater than 5, strictly greater than 5. We don't have that letter line or equal to. That means the 5, we skip the 5, it's not included. So the 5 is here, but we actually starting from, we can still make it look like we start from 5, but we do that with an empty circle, which means that 5 is not included. You notice here we used a shaded circle, but for the 5, we use an empty circle, meaning we gotta skip that 5. It's not included. There's a hole in it. Basically, anything that's greater than 5 is fine, not the 5 itself. And that's basically the difference between these two little lines here. So when you have or equal to, start from that number. And we say that on the graph by shading the letter circle or the starting point. But if you don't have or equal to, that means that this number is not included. But we still start from 5 technically, but without including it. So we use that circle. We use that circle to mean that it's not included. Okay, same thing works with if you have less than, let's say x less than, let's say negative 2. So graphing this, you always need a graph. You need 0 in the middle. You don't have to put all the numbers here and the numbers here. Just put the number that you have. On which side of the 0 would the negative 2 be? On which side? Where would you find the number negative 2 on the number
On
line?
the left side. On the left side.
That's right. It will be somewhere over here. This is negative 1, maybe negative 2 over here. So this here, we want the numbers that are less than negative 2. All the real numbers, or x that's less than negative 2. So we're going to start
Minus
with negative 2. Then where do you go to get the numbers that are less than negative 2? Do we go right or left?
left.
That's right. We need to go to the left of this. So less than, always go to the left. Because the numbers get smaller as you go this way, but greater than, always go to the right. That's where the numbers get greater. Is this number negative 2 itself included or not?
Not included.
Okay. How do we say that we're not included? We're skipping it.
Because there is no sign that it's equal.
That's right. We don't have or equal to. So that means we're not including this. How do we say that on the graph? How do we show that this negative 2 is not included?
We don't shade a circle.
Exactly. So you're going to use an empty circle like this.
Yes.
Okay. So we want the numbers x that are less than negative 2. So less means go to the left. But this point, sometimes it's included, sometimes it's not. If we have or equal to, that extra little line here, that means that number itself is included. Start from that and go to the left. Or if you don't have that line here, that means that number is not included. And we show that on the graph by putting an empty circle there. So any number that's from here to the left, not including this, so this is not including the negative 2, is part of the solution. So the solution here, or this inequality, we can graph it. So any number here is good. So when we have this and this, so we use shaded circle, which means include. Include whatever number is here. However, if you have only this and this, without those little lines, on the graph we use an empty circle as opposed to a shaded one. So this means exclude or not include. Okay, not include, or you can just say exclude. It's the opposite of include. Okay, that's the graphing part. So you can do the same thing if you have same one. So let's do this one with that letter line. So if we have this, so this is x less than -2. This is x less than or equal to -2. They're almost the same. The only difference is this one will have a shaded circle because we have that letter line, which means include. Okay, so we're going to include. It's going to look like this. So -2 here. And this time we're going to use a shaded circle because we want to include the -2. So x less than or equal to. Or equal to, that or means start from -2 and go to the left. So that's basically how we graph every solution possible. So the graphing is quite easy, but sometimes the inequality is not always in this form, which is convenient. The x is not always by itself. It could be like this or like this. So we don't know how to graph this yet. We don't know how to graph this yet. First, we need to solve them and make them look like this. Basically, we need to get the x by itself. Only x, no negative, no number or fraction. Once we solve them, similarly to solving equations, so we do a couple of things on both sides. So until we isolate the x and solve it. Once you isolate your x, you basically end up with one of these cases. Okay, so now let's look at solving inequalities. Okay, start with something simple, maybe x plus 1 is greater than or equal to 3. So when you solve inequalities, you can always think of this as an equal sign. Okay, so you can always think of this as an equation, and you pretty much need to do the same thing we do with the equations. So to solve this equation, for example, what do you do? To solve this equation or to get the x by itself, what's the one step that you need to do here?
3 minus 1.
That's right, we do -1 on both sides. So
Yes.
it's the same steps as, so this is what we had initially. So think of this as an equal sign and do the same steps. So to solve this, we just need to subtract or cancel this one to get the x by itself, also here. So these cancel out, so we end up with x greater than or equal to 3 minus 1 is 2. That's it. Once you get that x by itself, that's the solution of the inequality. And then we just need to graph it on a number line. So x greater than 2, 2 is positive, so it's going to be here. So I want the numbers x that are greater than or equal to 2. So where do you start? Where do you go from here?
From 2.
Okay, are we including the 2?
We include 2 by shading the circle.
That's right. So we have 2, we have this little thing. That means include the 2. So we're going to shade the circle. So we want the numbers x that are greater than 2. Greater than 2, do we go right or left?
We go right.
That's right. We're going to go to the right. And that's pretty much the process every time. You solve, then you graph. So make sure you isolate the x first. You got to get it by itself without anything with it. Just the x by itself, a positive x. And the inequality could be simple like this or like this, but it could be a little more complex like this. But the steps of solving inequalities are the same as solving equations, except for one little exception we're going to see in a moment. Does that make sense to everybody so far? Jessica, Kiara, Lordine, you guys okay?
Yeah. Yes.
Okay, so please let me know.
I've done this before. Yeah, I'll ask if anything.
All right, so let me know if you have any questions anymore. Let's make this a little longer. Maybe let's do that one here. 2x minus 7. Less than, or 2x minus 1 less than 7. This took one step to solve. This is going to take more steps. How many steps is it going to take to solve this one?
2 steps.
2 steps. So the first one is to cancel the negative 1. Then we cancel the 2. Let's cancel the negative 1. I'm going to add 1 to both sides. End up with 2x. These cancel out, less than 8. What do you do next to get the x by itself? Did you cancel the 2? How do you cancel the 2?
We divide by 2.
That's right, we're going to divide both sides by 2. Isolate the x, and we end up with 4. As always, number line, 0 on the middle. This is a positive number, so it's going to be on the right, somewhere here. Again, you don't have to write all the numbers on the number line like this. Just write that specific number you need. So we want the numbers. Is 4 included?
Not included.
That's right, 4 is not included. So we're going to use this empty circle here. Do we go right or left? Less than.
We go left.
That's right. So less than, always go to the left on the number line. So we're going to go this way. And that's the solution. Let's look at that one itself. So we're going to do 3x plus 1. Or actually minus 9. And greater than negative 12. Again, always think about this as an equal sign. And do the same, pretty much the same steps we do for the equations. Okay, think of this as an equal sign. So what do you do first in this inequality to solve it? Same thing as we did in the equations. What's the first step?
Remultiply x and plus 1.
That's right.
And 1.
If you have parentheses, distribute first. To clear, okay, to clear those parentheses. So we're going to go this way. So 3x plus 3 minus 9 greater than or equal to negative 2. Now we're going to work on this side, combine like terms. Looks like we can combine positive 3 and negative 9. What's positive 3 minus 9?
Minus 6.
Right? Will be 6 greater than negative 2. And now we're down to something like this. So 2 more steps again. We're going to cancel the negative 6 and then cancel the 3. How do you cancel negative 6?
Plus 6.
That's right, plus 6. Plus 6 on both sides. Just like with equations, we did the same thing on both sides. Inequalities also need to be done the same way. We need to do the same thing on both sides. So greater than, what's negative 6 or negative 12 plus 6?
Positive 6.
Not positive 6, but negative 6.
Oh, negative, yes.
Okay, the sign of the higher number. Finally, divide by 3, divide by 3. So x is greater than negative 2. As always, number line, 0. So this time, the number here is negative, so it's going to be on the left of 0 somewhere here. So we want the numbers that are actually, yeah, that's right. We want the numbers that are greater than, so this means greater than. So we're going to go to the right.
To the right.
That's right. And not including the negative because we don't have this line here. So it's not included. And we see that on the graph by using an empty circle, which means skip that and move on to the right. And these are all the possible scenarios you may see. And the rest is pretty much, like I said, similar to solving equations. There is one, let's see, let's do one more example here. Sometimes, just like with equations, you may have x's on both sides. You may have variables and variables and numbers on both sides of the inequality. But again, the steps are the same. So what do you think we do here to isolate the x, to solve the x? So how do you
Combine them?
And how do you combine? Exactly. Do you do?
5x and minus 4x.
That's right. So we have the inequality sign. We have x here and here. So we want to have the x on one side. So we're going to move the 4x here to this side and move it across the equal sign. And when you move something to the opposite side, you got to switch the sign. We're going to change the sign of this because it moves to the other side. So this turns into, at the same time, we're going to move the -2 back here to combine it with +3. And when you move the -2, it will change the sign from negative to a positive. So this will be 5x. Positive 4x invisible positive turns into a negative 4x. Because we moved it to the other side. The comparison sign is here. Then the -2 will be moved over. So the negative turns into positive 2. Hello again. I think I lost you for a couple of seconds there, right?
Yes. Yes.
Okay. I think we got disconnected for no reason. Sure. Okay, let me share this again. All right, so we were talking about this example. So we moved 4x over, we moved the -2 over. When you move something across the equal sign or across the inequality sign, you need to change the sign of that term. So positive turns into a negative. -2 moved over, turned into +2. We bring down the +3. We didn't change the sign because we didn't move it. It's still on the right side. So now we can simplify and combine like terms. So we have x here for 1x less than 5. That's it. So once you get the x by itself, that's the solution. So we need to graph it. As always, 0 in the middle, 5 is positive, so it's going to be on this side. So we want the numbers that are less than 5. Less than means go to the left. And the 5 itself is included because of this letter line. It means less than or equal to. Or equal to 5, that means the 5 itself is included. So we're going to use a shaded circle like this. And that's pretty much it, how you solve and graph inequalities. There's one little exception here, one little special case when you have, let's say you have -2x, and you have greater than 6. So here, this is a one-step inequality. So to solve this, we need to divide both sides by what? We divide both sides by,
But
say again?
by 2.
Not by 2, but by -2. So we want to cancel.
-2, yeah. -2.
We want to cancel the negative. So we're going to divide both sides by -2. Only thing here is, since we divided by -2, this will have to face to the opposite way. Only when you divide or multiply by negative, you need to switch the direction of the inequality. So it goes that way. So that now -2 and -2 cancel out. You end up with x by itself, less than 6 divided by -2, which is -3. And to graph this again, we just do the line and the -3 is here. So we want the numbers that are less than, so we go to the left. Negative itself, -3 is not included, so we're going to use a circle. Okay, so that's a special case, so be careful if you divide by negative, or if you have a negative next to the x, -2, -1, negative whatever, you have to divide by that number. If you divide by negative, you need to switch the inequality to the opposite side. We did not switch the sign here when we divided by 3 because this is a +3, we divided by 3. So this stays the same. But be careful when you have a negative to need to switch that to the other side. Let me explain why. So let's take some simple numbers. So for example, 5 is greater than 2. That's a true statement. What happens if you divide both sides by -1, for example, or any negative number? So if you divide here by -1, if you divide here by -1, what's 5 divided by -1?
-2.
Now what's 5 divided by -1?
5. Not -5.
It is -5. Positive divided negative is negative. And here, 2 divided by -1 is
-2.
-2. So here 5 is greater than 2, makes sense. But now, this inequality, do you think -5 is greater than -2?
No.
Yeah.
Because if you have 0 here, -2 is here, -5 is here. With 2 and 5, we're here. It is true that 5 is greater than 2 because 5 is to the right, 2 is to the left. So the numbers on the right are always higher than the numbers on the right. I mean, the numbers to the right are always higher than numbers to the left. So once you multiply by a negative or you divide by negative, so these numbers turn negative. So now, if you look at -5, -5 is not greater. -5 is to the left of -2. So -5 is actually less than. Okay, -5 is less than -2 because -5 is here, -2 is here. So as you go to the left, the numbers get smaller and smaller and smaller. So that's the reason why we flip the inequality sign to the opposite side, only again, if you multiplied both sides or divided them by a negative number. Okay, does that make sense?
Yes, sir.
Yes.
Okay, so be careful with that when you solve on a graph. The question will not tell you this or that, so you have to figure it out. There's another case. So -x less than or equal to -3. First,
This is going to be in the midterm? I'm sorry.
yes, this is the last topic.
Okay. Okay.
So -x less than or equal to -3. So again, before you graph an inequality, you have to solve it. It has to be like this. Only x by itself. No negatives next to it, no 2 here or no fraction, no number after. So you want to isolate the x by itself. Here, the x is not by itself. What needs to be canceled? Or how do you isolate the x? How do you get to make the x? How do you get the x by itself?
Divide by x or by 1.
Not divided by x, but divided by negative. Remember here,
Negative.
x. invisible negative 1. Okay, so there's always an invisible 1 or negative 1 to the x. For example, here it's just 1. No need to divide by 1. 1x is the same as 1. Here it was negative 2. Sometimes it's 3. There's always a number next to the x. So if you see a negative next to the x, that means it's a negative 1. So now it kind of looks like this. So we're going to apply the same steps we did here to solve this inequality. So what do you think we do now on both sides to solve this inequality? What do you do on both sides to get the x by itself? Again, think about this example. It's very similar.
We divide the x by -1.
That's right. So we're going to take the negative
Negative 1.
negative 3. We just need to divide both sides by negative 1. And what happens here?
We have unequal numbers.
So
Equal numbers.
what goes here? What goes in? What comparison sign goes here?
Equal.
No, think about again the previous example.
Greater.
We change the sign
Why do we change it to the other side?
because we divided by negative number.
Exactly. So we had to divide, to cancel the negative 1, we had to divide by this negative 1. Since we divided by negative 1, as we explained here in here, we have to flip this to the other side. So now negative 1 and negative 1 cancel out. We have the x by itself. Then greater than or equal to, what's negative 3 divided by negative 1?
-3.
No,
Not negative, +3.
positive 3. So negative divide negative.
Right.
Just like multiple. The rules are the same as for multiplication and division. So negative divided negative is a positive. That's it. Once you get that x by itself, no negative or anything, so the equation is done. All you have to do is graph it. As always, 0 here, 3 here, and x greater than or equal to 3. So we're going to the right, including the 3 because of that little line. Okay, so be careful with that exception. Make sure you know when to switch or to flip the inequality sign to the opposite side. And that's pretty much how you deal with inequalities. They're not hard to do. You just need to first isolate the x, similarly to what we do with equations. Once you isolate the x, basically we graph it because inequalities have many solutions. So for example, when x is greater than 5, any number that's greater than 5 is a solution. So we have many solutions, that's why we use a number line. As opposed to equations, for equalities, first degree equations usually have one solution or none, or sometimes many. So we don't need a number line to graph them. We just, especially when you have exactly one solution. So it's just x equals this, for example, that specific number. So everything we learned before about equations, including the fractions we did before, applies here. So if you have fractions, find the LCD. So for example, if you have, so x over 3, maybe 1/4 greater than, let's say, 1/6. So all the stuff we learned about equations applies to here. So the only difference again is this comparison sign, but treat it the same as an equal sign while being careful with this case when you divide or multiply by negative. Okay, so we want to solve this inequality first. So I'm going to get the x by itself before graphing it. So what do we do first in this equation with multiple fractions? What do you find first?
X.
we need to find x. We need to get the x by itself. So what do you do? What do you find first? We need to find x, but how do you go?
Yes, we divide -1/4 by -1/4.
If you remember from the equations, when you have multiple fractions, we want to try to cancel them. You want to try to
Yes,
cancel.
we are canceling it. Yes.
How do you cancel fractions? We need to find, to cancel all these fractions, we need to find something else.
Denominator.
The least common, the LCD, the least common denominator.
Least common.
The easiest and fastest way to cancel all these fractions. What is the LCD for 3, 4, and 6?
12.
12. So find LCD is the first step. And then you multiply by LCD. We multiply the entire equation or inequality by 12. That way, as you're going to see, all the fractions would cancel out at the same time.
Sorry, Professor. Let me ask you, why is 12? I'm sorry, I didn't get that one.
So, because all of these go into 12. So 3, 4, and 6.
Mm-hmm.
These numbers go into 12. So this is the least common multiple. If you do multiples of these, 3, 6, 9, 12, 4, 8, 12, 6, then 12. So,
Okay. Yes.
again, you can always go back to the part when we talk about equations. We showed how to find the LCD and why and how to cancel it. So this is very simple.
Yeah.
So now that we know the LCD is 12, we're just going to basically multiply. We're going to write 12 next to each fraction, all of these fractions, so 12. And also here, 12. Okay, so you write the 12 next to all of them, and what do you do next? Remember, we're trying to cancel the fractions, so what are we going to do now?
We multiply each fraction by 12.
So that's what we wrote here, but in fact, we're actually not multiplying yet, so we're going to try to cancel with the fractions as we saw with the fractions in the first or second day. Always simplify them first. So first you write the LCD next to each fraction, and before multiplying, reduce or divide, and all the fractions will cancel out. So 12 by 3 would be
4.
4, that's right, and then you have times x, minus 12 by 4.
3.
That's right, that's 1 times 3, so 12 by 4 is 3, times that by 1. And then same thing here, so 12 by 6.
2.
2 times that by 1, you get 2. So that's how you quickly get rid of the fractions. If you have different, multiple fractions, find the LCD, put the LCD next to each fraction, and then reduce first. Reduce before multiplying. Now it's much simpler, and it's similar to what we've seen earlier, like here, or also here. So we're going to add 3 to both sides. So 4x is greater than 5. Then divide by 4, divide by 4. So x is 5 over 4. So 5 over 4 is 1 and some change. So if you turn this into a mixed number or as into a decimal, 5 over 4 is 1 and 1/4, right? So you turn this improper fraction into a mixed number. So 4
Yes.
ones and 1/4, which is as a decimal. So before you graph fractions on a number line, you need to turn them into decimals or at least into mixed numbers to see where to start from. So this is 1 and some change. So this is basically 1 and, what is 1 over 4 as a decimal? 1.25 as a decimal is 1 point what?
1.25.
Right, 1.25. So before you graph your fractions, simplify them first if you have to. Turn them into maybe a mixed number, or you can just turn them into decimals. Again, we talked about this in detail about how to turn improper into mixed numbers, how to turn fractions into decimals. So we've talked about this in the previous classes, the first 3 or 4 classes. So now that we have it as a decimal, we can go ahead and graph it. We have 0. On what side would 1.25 be on this number line?
On the right side.
That's right. So 1.25 would be here. Somewhere over here, very close to 1. So there's 1 and then 1.25. So we need to go to the right. Greater than means go to the right. Not including the number itself because we don't have the letter line, not including it. So this is 1.25, and then we go to the right. Okay, so that's another case when you have fractions. Again, you can always go back and review the part of the fractions. In solving equations with fractions, it's similar to this. And also make sure you review your fractions, now how to simplify and turn them into mixed numbers or turn them into decimals. Okay, so that's just in case you run into one of these in the homework, so no big deal. Do the same thing we did with equations. Does that make sense, everybody? Any questions?
No questions.
Okay, everybody else? Guys, okay?
Yeah, that's fine. Kind of, but yeah.
All right. So that's pretty much it for inequalities. Like I said, it's a simple topic. And basically, the only new part is probably this part of graphing. The rest is like solving equations, also the fractions. We saw that before. So review those if you still have confusions about fractions and decimals. You may want to review those first. And also, feel free to rewatch this. I'll upload this lecture to Blackboard. Always highly recommend that you rewatch it, especially if you think that you need more time or need more help. So rewatch that. It will definitely clarify things a bit further. I will also post a few questions for the homework from this, just a few, and it will be the last homework before the midterm. So again, the midterm is on Thursday next week. The review is on Tuesday. So finish up your homeworks, study the review sheet. We're gonna start reviewing starting from the next class. Since we were done, the next class, I'll take any questions you may have from either from the review sheet, or if you still have any questions from this or the previous lecture, I'll also take questions from that. Okay, so any questions for me today, everybody?
No questions.
Okay.
I wrote a question in the Blackboard, so I hope you'll let me know. It's about the homework.
All right, let me go to Blackboard. So everyone, please log into, make sure you leave comment or question on the discussion board. You have to do that every class for attendance purposes and for also participation. And it's an ongoing forum that you can check out the whole, every time, it's open the whole week.